Hey guys, it's Nakami again. Here to show you how to solve for a particular variable in an equation that might have more than one variable. A lot of kids tend to freak out when they see something that just has a is equal to bx plus c and they're asked to just solve for x, which kind of is confusing at first, but then you'll realize if you just solve it like you normally solve any equation, it's pretty much the same thing. It's just now with letters instead of numbers. So what I have over here is the same exact equation, but I replaced the a, b, and c with some numbers. And for some of you guys, you already started solving this without me even telling you, because you've done this so often. Like some of you already know, with this plus 5, you need to subtract 5 from both sides, right? So if I subtract 5 from both sides, I end up with 5 equals to 3x. And then after that, you already know you're supposed to divide both sides by 3. And you get your final answer, which is this fraction, 5 over 3 is equal to x. And that's solved for x, right? You do the same exact thing with this a, b, and c stuff. We're going to go ahead and subtract both sides by this c, just like we did with that 5. That c is not what I want isolated. The x right here is what I want isolated, just like I wanted over here in the other equation. So I go ahead and subtract c from both sides, and this is where most people freeze. They're like, well, I was able to do 10 minus 5. That just simplifies to 5. I don't know what a minus c is, and no one really does. And all you have to do is just write it down as a minus c. That's it. A minus c is a representation of some numbers that are going to subtract. We just don't know what those numbers are. So we have here a minus c is equal to b, x. And just like when we divided by 3 over on this side, we're going to be doing the same thing. We're going to be dividing by b over here because bx represents b times x. And the opposite of multiplication is division. So we divide both sides by b. And over here, we're going to divide the entire side by b. You see, this a minus c that you have in this equation right here, well, by the way, this is your answer. This a minus c, if I highlight it, it's the same representation of this 5, right? It's basically just this 10 minus 5 that's going on. See that? And the division of this b is the same thing as, onto both sides, is the same thing as dividing by this 3. Same exact idea. It's just now you have letters there instead of numbers, and you do the same operations as you normally would. Let's go ahead and write off this final answer here. We're going to be having it as a minus c over b is equal to x, and that's how you solve for a particular variable. If you're still struggling with this when you have a new problem, one tip that might be helpful to you is to get you used to this, is to replace the variables that you're not solving for with a particular number, right? It could be anything. Like, for example, let's say I have here the volume of a rectangle, right? The volume of the rectangle is equal to length times width times height. Length times width times height. And let's say I was asked to solve for, let's say, w. So that's this guy right here. I'm trying to get this w isolated, right? And again, some people kind of freak out because they're like, oh, it's surrounded by a bunch of variables. Well, if it helps, you can replace all the other variables you don't care about with a random number. For example, since I'm only solving for w, I can replace the v with, let's say, I don't know, 5 is equal to 3 times w times any other number, like 7, for example, right? And if I want to, I simply just have to realize that if I'm trying to get w by itself, I need to divide both sides by a 3 and divide by another 7. Right? That way the 3's will cancel each other out here and the 7's will cancel each other out here. But I do it to one side, you have to do it to the other side. So over here we'll have a 3 divided as well and another 7, right? I don't really care what that's going to come out to be, but do the same thing with your original problem now. You see that you need to divide both sides by an L, that way the L's cancel out, and you need to divide by an H as well, that way they'll cancel out on the right-hand side. Right there and right there. But what you do to one side, we're going to go ahead and do it to the other side as well. Divide by an L and divide by an H. So my final answer will be that W is equal to V over LH. That's it. It's solved for a particular variable. Sets up the same way when it's addition and subtraction. Do the opposite to get that variable by itself. Let me show you one more example, and I promise you I'll be done with this video. Let's say I have here, I'm just going to make up an equation here. Let's say I have V equals I plus AT. And I was asked to solve for let's go with I, just to keep it simple right now, right? I'm trying to get this I by itself, this I right here, right? What's with it? I have a plus AT. This is considered one whole term that I'm trying to get rid of, this AT right here. So I'm just going to go ahead and realize that this AT is adding to this I. So the opposite of addition is going to be subtraction. I'm going to go ahead and subtract AT from the right-hand side. But if you do it to one side, you have to make sure you do it to the other side. And you'll end up with an equation, V minus AT is equal to I. And you're done when your variable that you're solving for is isolated. Now, things might get a little bit more complicated when you have more than one variable. You have to deal with some factoring, but we'll deal with that in a future video. For now, hopefully this will get you ready for solving simple equations for a specific variable. Hope you guys have a good day, and I hope you guys are enjoying these videos. I'll talk to you later.